Hola a todos, buenos días. Nuevamente bienvenidos a la JConf Perú 2021. Estamos aquí nuevamente con Reza Rahman en la charla Effective Kubernetes for Jakarta EE and MicroProfile Developers. Reza es Principal Program Manager for Java en Azure, Microsoft. Trabaja para asegurarse de que los desarrolladores en Java sean considerados como ciudadanos de primera clase, obviamente dentro de Java, y que Microsoft sea considerada como un ciudadano de primera clase dentro del ecosistema Java. Es autor del popular libro EJB3 en Action de Money Publishing. Ha sido speaker muy frecuente dentro de la comunidad de Java User Groups, como lo estamos viendo ahora, y de conferencias a nivel mundial, incluyendo JavaOne y Devoxx. También ayuda en el liderazgo del grupo de usuarios Java de Filadelfia y es un orgulloso miembro fundador del grupo de embajadores Jakarta EE. Ha sido líder del track Java EE en JavaOne y ganador del JavaOne Rock Star Speaker Award. Fue Program Chair en la conferencia inaugural de JakartaOne. Reza es un ávido contribuidor de periodistas, ¿cómo se llama? Hacia los periodistas de tecnología como DZone. Es miembro de los grupos expertos de Java EE, EJB y JMS. También ha implementado un EJB container para el proyecto open source Resin. That's it. So Reza, you can start now.
All right, so I'm going to begin sharing my screen. Let me know if you can't see it. You should be able to. Let me hide this thing here and then go over here. All right, so what is the talk today about? The talk today is about how to use effective use of Kubernetes if you are a Jakarta EE and MicroProfile developer. There's several key concerns that I'll be covering throughout this talk. Most of the talk obviously is ideal for somebody that's using Jakarta EE or MicroProfile runtime with Kubernetes. But honestly, even if you're not and you're using some other Java runtime like Spring Boot, I think you'll get about 60 to 70% of the material here. And if you don't happen to be a Java developer, probably you're looking at maybe about 30 to 40% of the talk. So just want to be clear about who the ideal audience is and what you'll get out of this talk depending on what technology stack you happen to be using. So this particular talk is actually, it's not a talk. It's in fact a workshop. So I do not have any slide decks for this workshop at all. What I do have is a workshop materials itself. So the workshop materials are residing in my own GitHub repo. It's called Jakarta EE Kubernetes. I think you can Google it. It's relatively easy to find this repository. But the intent of this workshop is that you can log on and you use this material and basically go end to end and do this material, navigate this material in your own pace. Now, I have actually delivered this talk as a workshop. End to end, it's going to take you probably about 8 hours to finish. Obviously, we do not have 8 hours here. We have about 45 minutes. So what I plan to do is go over the workshop at a high level, tell you what exactly the workshop material is, and show you just about enough so that you can go back and take a look at this workshop material yourself and be able to make sense of it and be able to use it in your own pace. Now, obviously, you can reach out to me at any point in time. This is part of the reason I'm at these conferences. I'll do some Q&A a bit later. In fact, there's no reason to hold back Q&A. You can go ahead and ask questions as we go. I'll try to save some time towards the end for questions. But other than asking questions, frankly, I plan to give you enough so that you can go and be productive with this material yourself. So the workshop is broken down into several different parts, as is indicated in this repo. And let me increase the font size a little bit so you can see it a little bit more clearly also. So there, first and foremost, there is the basic Jakarta EE section. So this is nothing much more than taking the Jakarta EE application that I use throughout this demo and making it work in your local environment, in a non-cloud environment. This is a very simple Jakarta EE application. It's just using your regular Jakarta EE stack, JAX-RS, CDI, JSF, EJB, so on. And it's a simple CRUD application. But once you do that, there are several different things that we go over we will go over in this workshop in its totality. Obviously, not in this talk. One is to show you just a very basics beyond getting things running locally. How do you take that and create a basic cluster deployment on AKS or rather on Kubernetes? Um, and basically using very simple primitives like deployments, services, and so on. Now, for these examples, I will be using Azure as an example, but frankly, majority of this material you can use on any Kubernetes distribution, even maybe a Kubernetes distribution running locally using Minikube, if that's something you want to do. Now, beyond showing those very simple primitives, I'll also show you how to begin to take advantage of things like better observability in a Kubernetes environment using Jakarta EE and MicroProfile. So I'll show you things like self-healing and monitoring capabilities using liveness and readiness probes. I'll also show you how to use distributed monitoring using tools like Prometheus and Grafana that tend to be popular in the Kubernetes domain. Then I'll show you how to do all of this in a much more simpler way using operators. Most of the app servers, Jakarta EE app servers these days, actually do have operators. So I'll explain the operator way of doing things. And by the way, the app server I'll be using today is Liberty, but most app servers more or less behave the same way on Kubernetes. It's not very different. They're all sort of standardized on basic behaviors. Finally, the workshop also covers CI/CD. So CI/CD is a very important concept when you're doing any kind of containerization, in particularly Kubernetes. This is one of the things that it enables you to do. So the workshop shows you in very basic terms, how do you make all of this work in a CI/CD based environment. We use GitHub Actions as an example. Again, it's a fairly popular choice, but you can take some of these lessons and use it on something like Jenkins, for example. So with that, all of that being said, and also contribution to this workshop is always welcome. You're happy to more than glad to get any ideas, or if you run into any issues, if you want to contact me via GitHub, you can do so. So without further ado, let's get started. So here's the basic Jakarta EE application. So this is step-by-step instructions on how to do all of these things. Obviously, to save time, I've done a few things ahead of time to save us time. So I've already installed JDK 11. I already have Eclipse IDE for enterprise developers installed. I already have Liberty set up in my Eclipse environment and in my local environment. I will be using Docker, even though we're not using on the cloud. I'll be using Docker for a small portion of the demo. I'll explain to you in a moment why that is. And you need this repository in your code, which I also have downloaded on my local machine. Since this is a CRUD-based application, you will need a database. The database I chose to use was Postgres. So you don't have to use Postgres. You can use whatever database you want. In case of Postgres, I could have run Postgres locally and done the entire installation. But actually, one of the powers of Docker is that you don't need to do that. You can very easily spin up simple things. If you don't want to do a local install, you can just run it temporarily through Docker. And in fact, this is what I'll choose to do. So I'll show you the Docker syntax. In fact, let me increase the font size here a bit more so that you can see the commands a little bit more clearly. Okay, hopefully you can see that. So the command here is docker run the Docker image. The Docker image I'm running is Postgres. So I'm running the Postgres image that is already in Docker Hub. I am specifying a few different things. The most important thing is I'm opening up the database in port 5432, and I'm also loading up a persistence volume. This is something you need to do because in case of Docker, Docker basically, Docker images go up and down. So what happens if you take down the database? You can't have the file system itself also entirely go away with the pod. So what you can do is you can load up a local file system as though it is loaded up in the pod using these persistence volume mechanism. So let's go ahead and start the Postgres database. All right, so the Postgres database is now up and running. We can begin to use it. In order to run the application, here's step-by-step instructions on how to do that in Eclipse. I've already taken a majority of these steps, so everything is set up in my environment and ready to go. So here's my Eclipse-based environment. I do have OpenLiberty set up here, as you can see. And here's my application. The application is a very simple Jakarta EE application. The only dependency it actually has is on Jakarta EE, and that's about it. So I'm going to go ahead and run this application locally against the local database. So let me first do a clean and a build. Maven clean. I'll do a Maven package or install in this case. All right, so that's done, and I'm going to just run it on the server. Yes, run it on Liberty. And of course, whenever you're running a demo, something will go wrong. Hopefully not. Okay, so I already have some data populated. I'll just show you the application real quick in my browser. So it's a simple CRUD application. I'll just delete this one, entry here, recreate it for you. So there you have it. There's also a REST-based interface for this application. So here it is. And as you can see, there's the REST endpoint. It's producing XML. It could easily be producing JSON. And it also, the same endpoint also will support things like query by ID. So let's query by, for example, this ID here. And as you can see, that's querying by one. Similarly, you can do a delete and an update operation and an add operation through this CRUD interface also. In fact, the UI that you saw is really nothing much more than a JSF facade over this RESTful interface. Okay, so that's it in terms of the local setup of this. I'm actually going to just shut down the IDE because I don't really need it for the rest of my demo here. Okay, the IDE is shut down. All right, now let's take this application and begin to run it on the cloud. So here's the instructions on how to do that. You will need a Azure account for this particular demo. You could be running it on another cloud. And on the cloud, we will be using Postgres, just as we were before, but we will be using Postgres on the cloud. So I already have this set up. So here's my resource group. A resource group is sort of like an abstraction over a grouping of resources on Azure. So if you can think about it as a data center here. So I did create two different things beforehand. So I created the Postgres database. So here is the Postgres database. As you can see, there's a bit of activity that I've been doing on this Postgres database. So we have the database up and running, and it's available to the application. And also to save time, I have gone ahead and created a Kubernetes cluster. This usually takes about half hour to provision. The database also takes about half hour to provision. Obviously, we don't have time for all that, so I needed to do this beforehand. And if you look at, for example, the insights, you'll see that there's some activity in the database, in the Kubernetes cluster already. I'll show you the state of the Kubernetes cluster. I also have I'm also connected to the Kubernetes cluster locally from here. So there's a database set up the Kubernetes cluster, and I've already set up my AZ, my kube control environment, my command line environment that I'll be using to interact with Kubernetes. In order to do that, you just need to run one command. This is the command here. And so I've already gone ahead and run that command. I'll show you the output, the result of what happens here. So let me Control C out of the database. We do not need that anymore. Just clear that out. So let's do kube. And I'm going to go ahead and go into the clustering directory before I forget. So here's the clustering directory. And I'm just going to do kubectl get nodes. And there should be only one node for this application. It's a simple application. I just have one node set up for it. We can do get pods. Okay, and you'll see there's no pods. We can do services. And we'll see that the only service that is running right now is the Kubernetes cluster itself, and that's about it. So it's a pretty empty cluster right at this moment. So now we're going to begin to populate this cluster with stuff. So the first thing that we're going to do is that we're going to set up a Ingress controller. Now, why is that? You can just use a Kubernetes service if you wanted to, and I'll show you a Kubernetes service way in a moment also if there is time. But this is a stateful application. In fact, I'll show you the stateful portions of this application in a moment also. And because it is a stateful application, and you can also take a look at the server config here. Okay, you'll see that there's the admin center that is enabled here. So because the admin center is enabled, this is a stateful cluster. So for a stateful cluster, you need sticky sessions in order for that to function correctly. So in order for sticky sessions to work, the default load balancer, at least on Azure and most of the clouds, are not that sophisticated. They're simply TCP/IP round robin scattering of HTTP traffic. That's about it. It will not support things like sticky sessions. So in order to enable sticky sessions, you need something a little bit more powerful, and you need an Ingress controller. So that's the use case for an Ingress controller. You can use something like Azure App Gateway as an Ingress controller, but in this case, we're simply using Nginx. So there's a couple of different commands in order to get Nginx up and running in this cluster. Essentially, what you're really doing is setting up the Ingress operator. So there's several different. These are the commands that you need to do that. You need to create a separate namespace. We're going to create the Ingress in a separate namespace. You need to add the repo where the Helm chart for Nginx is available, and then you need to install Nginx as an operator in the cluster itself using Helm. And once you've done that, you will basically have a separate namespace. And I've already done these commands beforehand because it takes a little bit of time for Nginx to be installed. So you can do that. You can see that by saying kubectl get namespaces. And you see that there's this Ingress basic namespace that I have created beforehand. So let's go ahead and take a look at what is running in that namespace. So this is the command to do that. All right, so as you can see, Ingress basic namespace, and I'm going to get the services in that namespace. So I can remove watch from here, actually. I don't need it. So you see that there's a load balancer created that has an external IP to it. This is our Nginx endpoint. So let's go ahead and exercise this Nginx endpoint. Right now, we will get a 404 because there is no backend service running yet. So it is just the Nginx operator that is installed using these few commands. Now, the next thing we're going to do is actually deploy the application. So we already have a WAR file of the application. What we need to do in order to do the Kubernetes deployment is create a Docker image and publish that Docker image before we can use it in Kubernetes. So that's what we're going to do next. So the first step I'm going to do is go ahead and copy over the WAR file that we had created just a little bit earlier. Actually, let me just do this fresh. So let's go in here. And we'll go to the Jakarta EE directory. There's the Jakarta EE application, cafe application. There's a POM file. I'm going to do maven. Clean package. All right, there's the WAR file that was created. One more. All right, so going back in the clustering directory, let's copy over that WAR file now. copy. And we're going to copy it into the clustering directory. So here we go, paste item. We'll do our replace. All right. So once we've done that, we're going to do a Docker login because the next step for us is to actually go ahead and upload this, build the Docker image and upload it into Docker Hub. So I'll go ahead and do my Docker login. All right, so I am logged on into Docker Hub at this point. I'm going to go ahead and build the image. First, let me build the image and then I'll show you the Docker file that I'm using to build the image. So my Docker Hub repo is called Reza Rahman, my full name. And it's simply Docker build the name of the Docker image, which is the fully qualified name, including the account name, the image name that I want to give it is Jakarta EE Cafe, and I want to give it a version of V1. So let's go ahead and build this. All right, so that is built. Now let me show you. If we do an ls here, you will see that there's a Docker file here. Let me show you the Docker file. All right, so it's very, very simple. In this case, we are starting with web shared liberty. Since we're connecting up to the database, I need to copy over the Postgres jar file into the resources directory inside the image for liberty. I need to copy over the liberty server.xml, which is very, very simple. I'll show you what's in the server.xml in a moment. And finally, I need to copy over my var. So let me show you what's in the server.xml. We go up here in the server directory, and here's the server.xml. And it's very, very simple. I'm simply enabling the admin console, which we will use. And I'm the only other thing that I'm really doing here is setting up the session cache. So actually, we'll deploy more than one Liberty instance, and all of these Liberty instances will actually be talking to, we'll be storing all of their session in a central database. So this way, I can take care of failover. Okay, and that is this command right here. That's this stanza right here. That's what that is doing. And then I simply have the database configuration. So again, the database configuration, the session storage using the database, so I can share my state across my cluster, as well as setting up the admin console. So I'll show you all of those things next by deploying the application. But before I can do the deployment, I need to push this Docker image. Now that I've built it, I need to push it into my Docker Hub. So let's issue a Docker push command in order to do that. Docker push. And again, I need to give it the full name. Okay, so that's there. It is pushed. Let's go look at my Docker Hub account to show you that it is in fact pushed. Right, I'll sign in. And if you go to my repositories, you'll see that this was updated. Jakarta EE Cafe was updated just a few seconds ago. So I successfully did my push. All right, after I do my push, I'm going to go ahead and create my deployment descriptor. I'm going to go issue my deployment descriptor. And before I do that, I'll actually show you what's in the deployment descriptor locally. So let's go back in here. If I do a ls, you'll see that there's a YAML file that is the Kubernetes deployment descriptor for this application. Let's take a quick look at it. All right. So unfortunately, this is not going to be that useful, or maybe it is. Let me scroll up. Yeah, you can see majority of the file here. So it is a type of deployment that is a primitive in Kubernetes. I'm giving it a name. Given the name I'm giving it is Jakarta EE Cafe. I want 2 copies of the application running, so it is load balanced. These are simply some metadata to apply for selectors. We'll use the selectors in a moment, actually. Inside of the server.xml, you'll see that we're using environment properties to actually connect up to the database. We're actually connecting up to, as you can see from the values here, we're connecting up to a database on Azure. And this is the image name that we are using, the one that we just pushed. Aside from that, you'll see that there's a kind of service, but the service is of type cluster IP. So all we're really doing is internally publishing the IP addresses of those 2 image in pods that we are creating. And the pods are running on port 9080 by default, but we are redirecting into port 80, and 943 is being redirected to 443. So here is the actual configuration for the Ingress controller. So you can see this is of type Ingress, and we are specifying sticky sessions here, cookie-based affinity, sticky sessions. And we are saying that the application, if we specify route, we just go to port 80, and if we specify port 443, we're going to go to port 443 in these pods. So let's go ahead and deploy this this Kubernetes application. So here's that. So we're simply deploying the deployment descriptor that we have here. All right, so our deployment is actually now done, and we can take a look at the results of the deployment. So we can do and we can see that both of the pods are now ready and they are running. So we'll Control C that one, and we'll do services next. As you can see, there's now 2 different services, Jakarta EE Cafe and Kubernetes. And so these are all up and running at this point. So now we can actually go ahead and access that IP address that we had from before again. So I'll go ahead and get the IP address of the operator once again. And the ingress is here. There's the IP address. So let's take this IP address now and give it a try and see what happens this time, now that we actually have a backend service. All right, so you can see that now I'm not getting a 404. I'm instead hitting one of the instances of Liberty. I can go ahead and try the application. So here's the application running, and I can also try Admin Center. This is a generated SSL certificate. You can install a real SSL certificate in production if you like. Come on. Okay, thank you. And so you can take a look at some basic information about the server, for example, the server configuration. And you can also monitor the application to some extent. So here's some data about the application, but this is just for one node. In order to do this across the cluster, you need to use Prometheus and Grafana. So that is about it in terms of the basic primitives. And of course, you should feel free to explore this application more yourself. But for now, I'm just going to hit delete on this cluster. All right, so the deployment is now deleted. So I won't have a tremendous amount of time. Looks like I have about 15 more minutes. So I'm going to skip over the Prometheus and Grafana portion, actually. And what I'm going to show you is the operator, so you can see how different the operator actually is. So all of the popular app servers do offer the operator way, so that's also very, very similar. So we'll use the operator this time. instead of using basic Kubernetes primitives, and we'll see how that looks like. So I'm going to go over to the operators directory. All right. So first I need to install the operator itself. And there's several different commands using different deployment descriptors that is going to apply the operator for me. So I'll go ahead and apply all of those. So this is the first one. All right, that is successful. Apply the second one. This is giving permissions to the operator to actually be able to do its work. All right, and that is fine. And then we'll actually deploy the operator itself. All right, so the operator should now be up and running. So we'll take a look at it. So we'll do get services. So there's the cluster IP. Let's do pods. And you can see that the operator is up and running as a separate pod itself. So this is going to help us ease our Liberty deployment and Liberty clusters. So when we deploy through the operator, you will form a true cluster, meaning that it's not just centralizing on just saving the state in the entire database. All of the pods will know about each other. So it'll do things like synchronizing for timers and synchronizing for scheduled asynchronous tasks, and so on and so forth. So we're going to do the same thing here. We're just going to build build the application. So let's go ahead and do that. All right, so now we have a WAR file. Okay, I'm going to build this version of the image, but I'm going to give it a v3 instead of v1. All right, and I'll show you the Docker. The Docker image is actually almost exactly the same. So, but I'm going to just show you this here. Let's go ahead and build and do a push, and then I'll show you the Docker file. So remember v3 instead of v1 in this case. Oh, wrong directory. Okay, we're going to go ahead and do the push next. All right, let's go ahead and confirm that the push actually happened. And we'll see that it was updated just a few minutes ago. Let's go take a look at the version tags to make sure. Okay, so v2 I haven't updated for a while, as you can see. v4 I haven't updated for a while, but v1 I was updated just 10 minutes ago when I did the demo, and then now v3 was just uploaded into our repo. So we're now ready to do the deployment. But let me show you the Docker file real quick before we do that. Okay, so you'll see that it's exactly the same. But if you dig into it a little bit more into it, you'll notice that the server.xml is slightly different in this case. Namely, we haven't enabled the admin console. Okay. All right, so let's go ahead and do the deployment, and then I'll show you what is actually being deployed. In fact, actually, let me do the reverse. Let me first show you what is getting, no, I changed my mind. Let's do the deployment first. All right, now let's make sure the deployment actually happened. Okay, so the operator is up and running, as you can see, and also we have two different pods, as you can see. So now let's take a look at the services. All right, so in this case, I have specified a type of load balancer. So because this is a stateless version of the service, we're not using the admin console, so we actually don't need to specify sticky sessions. So we can just get away with using just a load balancer primitive as opposed to using the cluster IP primitive from before. And let's go ahead and access the application, and then I will show you how different the deployment descriptor looks like in this case. All right, so OpenLiberty is up and running. And the application is also up and running, just as you would expect. So now let's take a look at the deployment descriptor and see how that differs. So here is the deployment descriptor this time. And you'll notice right away how much simpler this is. Right? There's really nothing much more, nothing to this compared to the complex deployment descriptor that we had before using all of the Kubernetes primitives. The reason for this is because this time we are deploying through the operator. So the operator knows a lot more about how OpenLiberty looks like. So it can abstract a bunch of different things. That's one thing. And as I mentioned, in this case, you are actually forming a native Liberty cluster as opposed to a cluster that is saving some state in the database, but ultimately the pods do not know them about themselves. In this case, the pods actually do know about themselves because everything is getting deployed through a centralized endpoint, namely the operator itself. So the kind in this case is not going to be deployment. It's going to be type OpenLiberty application. You'll specify some metadata as before. I am still keeping two replicas. You'll specify the image name in my local file. You'll see that this is Reza Rahman, Jakarta EE Cafe v3. And then we're specifying the environment variables just as before. And in this case, we're simply saying, hey, deploy a service for me in a very compact way. And the type of service should be a load balancer and do the port mapping. And that's how we're winding up with the load balancer deployment. Just to show you here, I'll show you the YAML. I'll get the YAML file for you here. All right, and as you can see, the image name is my image name in Docker Hub. So to recap, I showed you the operator way of doing things. I showed you the Kubernetes primitive way of doing things, showed you doing stateless load balancing, stateful load balancing, either using a type of service or using the Ingress controller and Nginx being the Ingress controller in this case. What I didn't show you, and I hope you will take a look at by yourself, is how to do monitoring above and beyond just the admin console way that I showed you. So you can use liveness and readiness probes. And in addition to liveness and readiness probes, you can use Prometheus and Grafana to do centralized monitoring of all of your Kubernetes pods. And then finally, you can use something like GitHub Actions or Jenkins to do the CI/CD on all of these things as well. So I think that is all the time that we have. We have about 5 more minutes for Q&A. Hopefully there is some Q&A. And I'm going to stop here and then move over and let us do Q&A for a little bit. So if you haven't asked your questions yet, please ask them now so I can answer those questions on your behalf. All right, any questions so far?
Not at the moment, Reza. I think we can wait a couple of minutes, so maybe a question can raise. Let's wait for it.
Yeah, no problem. If you guys have questions, please ask them now, or you can always get in touch with me later, of course. You can do the workshop yourself, and if you run into any questions, you can always get in touch with me. I'm easy to get in touch with.
There are some greetings. Some greetings here from Peru, Reza. No question yet. So a couple more minutes, and then we can wrap up.
Yeah, greetings to everyone. Hopefully, one of these days I get to see you guys all in person again and visit beautiful Peru. If you go on my blog, you'll see some very nice places. Last time I was in Peru, I actually visited Machu Picchu. So that was really quite amazing. And definitely, I look forward to all this COVID stuff getting resolved and maybe visit you guys again one day.
Yeah, we will welcome you again, Reza. I think there are no more questions. So thank you so much for the presentation, and well, we will see you again. I think there is one more.
I do have one more talk, yeah. So please feel free to join that, and that's a much more Azure specific talk. But yeah, welcome to join me in about an hour.
Thank you, Reza. El resto, chicos, nos vemos dentro de un momento más. Bye.